Hi, welcome back to AT Math. Today, 7-8, special products of binomials. Why? It's more fun.
Welcome to the miracle of the ball and the glass. As you can see, the red ball is inside the glass. And now what I'm going to do is reach through the walls of the glass and remove the ball. And that's the miracle of the ball and the glass.
Than a magic trick. Alright, well today we can go ahead and follow on page 501. So what I will do is I'm going to go ahead and in fact bring 501 right up here, which should be right here. Okay, and it says a perfect square trinomial is a trinomial based on the squaring of a binomial. In other words, if you take b plus 5 square, it just means b plus 5 times another b plus 5. So there's two b plus 5s, and they're going to multiply. Now if you remember, b times b and b times 5, and 5 times b and 5 times 5. So what you get is b times b is b squared, b times 5 is 5b, 5 times b is 5b, and 5 times 5 is 25. Now the only thing we have to do after that is combine this and this to make 10b. So we'll combine that to make 10b, and notice that is the answer now, b squared plus 10b plus 25. Again, we had a binomial that was squared, turned into a trinomial. So since it was created by squaring b plus 5, it is a perfect square trinomial. Now this, a plus b squared. Let's go ahead and take a look here. A plus b times another a plus b. A times a is a squared. A times b is ab. B times a is ba, but you could also see it as ab. It makes no difference. And b times b is b squared. Again, what I'm saying here is the b times a, if you put it as ba, it's still b times a and a times b. It doesn't matter which you switch them. Remember, you're a commutative property. It says that you can switch and multiply to either side, so it makes no difference. I'm going to put them both as ab because if I have one ab and another ab, I have two ab. Now I don't know what ab stands for, but I know there's two of them. So a squared plus 2ab plus b squared. You try, go ahead. Square this, get the perfect square trinomial. Square this, get the perfect square trinomial. Let's see how you did. Did you get this? I hope you did. Quick break. And back. And now we're going to take 4x plus 2y to the third power, and all of that's going to be squared. So what you do when all that becomes squared, you just go ahead and make two of them. Now we cannot just square all these guys from this square up here. You would say, why not? We did that before. Well, we can't because there's a plus or minus, because they're going to have to multiply each other as well. So when you see a square here, just spread them out, just one of each. And now 4x times 4x and 4x times 2w to the cubed, 2w cubed times 4x and 2w cubed times 2w cubed, like you see down here. 4x times 4x is 16x squared, 4x times 2w cubed is 8w cubed x, 2w cubed times 4x is also 8w cubed x, plus 4w to the 6th power. Now, interesting thing here is I have 8w cubed x, and there's two of them, but in this case, because there's a number out in front, this will become 16w cubed x. And this becomes 16x squared, and this is 4w to the 6th power. You try, go ahead. Remember to make two of them. So you're going to split that into two pieces. And you go ahead and this times this, this times this, this times this becomes this, and these two combine to make 16. Alright. Now, x minus 2 squared, same idea. Split them apart. X minus 2 times x minus 2. So x times x times negative 2, negative 2 times x, negative 2 times negative 2. Don't forget that two negatives make a positive, so this becomes positive 4. But here we're just going to combine these two, and it becomes like the following. So this is still x squared. this becomes negative 4x. Now you might say, wait a minute, you just told me that two negatives make a positive. Yeah, when you multiply, but when you're adding two negatives, it just becomes a bigger negative. Negative 2 minus 2 more is negative 4, x in this case, plus the 4. Remember, this was plus 4 because we took negative 2 times negative 2. You try. Go ahead. Remember, it's going to be x minus 5 times x minus 5. And there you have it. X times negative 5, negative 5 times x, negative 5 times negative 5, makes x squared minus 5x plus 25, combines to negative 10x plus 25. Now, take a break. And back. X times x is x squared, x times negative 5, 5 times x, 5 times negative 5. Notice here, though, with the positive and negative, we have the middle of a negative 5x and a positive 5x. What happens is these two actually cancel out. So these actually cancel each other out. They go away, leaving just x squared minus 25. So in this case, it doesn't become a perfect square trinomial. It becomes a binomial. And the reason why is we had opposites for the back part here, for the plus 5 and the minus 5. You try, go ahead. Notice when you work them out, you're going to get a minus 9x and a positive 9x. These cancel, leaving just your x squared minus 81. You try again. Bigger number, but you're AT, you'll be fine. Go ahead. Notice here, as these guys multiply, we have a middle now, but what this middle should be, pardon me, this should be a negative 27x, not a positive. So negative 27x squared. And these are going to cancel out, leaving 9 to the x to the fourth minus 81. Now, finally, the word problem. You can follow along on page 503. It says 7, 8. So let's take a look here. So page 503 right here, the koi pond. It says koi is, by the way, a fish, a small one, very popular to some people. They really like having these ponds. A square koi pond is surrounded by a gravel path. Write an expression that represents the area of the path. The answer will be an expression that represents the area of the path. To list the important information. The pond is the square of a side length of x minus 2. The path has a side length of x plus 2. Now, before you say, wait a minute, who would ever actually use this? You have to understand that you want to have a border here. Part of how your pond looks is based on how the border looks, and they're going to want to have certain pebbles or gravel, and depending on what kind of color you have will depend how your entire pond looks. And you could just have a regular round pond, but usually people want something a little more decorative. So to do this, you're going to say, well, how much water do you want? And however much water you want, that's going to determine how much border you need. And why would you care about that? Because if you have to go to the, let's say, Home Depot or a store where I live near, it's called Ground Effects, where you're buying a lot of something, you want to pick up the right amount the first time. Because if you're buying a whole bunch of it, you need it delivered. And I'll tell you what, when I went ahead and got some stuff done around my house, delivery cost $50 flat. Didn't care if they were dropping off a 10-pound object or a 10,000-pound object. Delivery was $50. So if we got the number wrong, we'd have to call them back for another delivery. That was another $50. So it made sense to do a little math, get the job done right the first time. Oh, between you and me, if you have to do stuff for home repair or home improvement, buy one or two more of something, so it's a lot easier to return it later than order another one from the store. Okay, anyway, so what we're saying here is the pond versus the gravel. Now they're saying the pond will be x minus 2 and the gravel is going to be x plus 2. So I'm basically thinking to myself, well, the gravel is probably going to be about 4 foot wide, but that's not the method we're going to use here. What we will do, we're going to take the area of the whole thing, which is going to be x plus 2 times x plus 2, versus the area of the small pond, or the pond inside, which is x minus 2 times x minus 2. Take a look here. So x plus 2, notice that it's a square within a square, as we talked about. The big square, x plus 2 times x plus 2, we'll do that. And minus the inner pond, which was the x minus 2 times x minus 2. So take x plus 2 times x plus 2. Notice x squared plus 4x plus 4. And then we're going to subtract the smaller circle. First we have to times these two to find the area of the smaller circle. x times negative 2, negative 2 times x, negative 2 times negative 2, x squared minus 4x plus 4. Now if we subtract big from little, so this minus this, remember when I put the negative I switch all these signs, as you're supposed to do. The area of the gravel around the pond is 8x. Now what does that exactly mean? That means when you fill this in, if you say it's going to be, well, we're going to start with a 10. So we'll say it's 8 foot by 8 foot. So if we put the letters, let's say 10 in here, we'd say, okay, so 10 minus 2 is 8. So we're saying our pond's going to be 8 by 8. We'd plug the 10 in and say, okay, well 10 plus 2 is 12, so we need 12 by 12. So you take your 12 by 12, which is 144, minus the 64. And notice here you would need 80 square feet of gravel if you wanted to have a 8 by 8 pond and you wanted a border of the same size. And if let's say you wanted a 20 foot, okay, 20 minus 2 is 18, so you need 18 square for your smaller one. 20 plus 2 is 22 square, so you take 22 square minus 18 square, and that would be the answer of square feet you would need. And there you have it. And so let's say, well, here I am answering my own question. So let's say I'll put 5 foot in there for this one. So I'll go ahead and take 5 minus 2, so that's 3 by 3. 5 plus 2 is 7 by 7. 7 times 7 is 49. 3 times 3 is 9. So 49 minus 9 is 40 square foot. But really, because we found out that it was simply 8x, I could just plug the 5 in and get 40 either way. However you want to look at it, it's good for you. We are done. Thanks again. Bye.